In 1964, a Soviet astrophysicist named Nikolai Kardashev proposed a radical idea. If intelligent life exists in the universe, we should be able to measure its progress, not by its technology, not by its biology, but by the amount of energy it can harness. This idea became known as the Kardashev Scale, a scientific ladder that ranks civilizations from planetary beginners to cosmic engineers. Tonight, we explore what Kardashev actually said, what modern astrophysicists believe, and what capabilities truly advanced civilizations might possess. Kardashev's original paper was titled Transmission of Information by Extraterrestrial Civilizations. He wasn't imagining alien empires. He was trying to answer a simple question. How powerful would an alien civilization's radio signals be? To answer this, he created 3 categories. Type 1, planetary civilization, uses all energy available on its home planet. Type 2, stellar civilization, uses all energy of its star. Type 3, galactic civilization, uses all energy of its galaxy. Kardashev believed that as civilizations grow, their energy consumption grows exponentially. And he believed Type 2 and Type 3 civilizations could exist. After Kardashev, other scientists expanded the idea. Carl Sagan refined the scale mathematically. He placed humanity at Type 0.7. He famously said, a Type 3 civilization would be indistinguishable from magic. Freeman Dyson introduced the concept of the Dyson Sphere, a structure that could capture a star's energy. He believed we could detect Type 2 civilizations by looking for infrared waste heat. Michio Kaku predicts Type 1 in 100 to 200 years, Type 2 in a few thousand, Type 3 in 100,000 plus years. He says each level requires solving an existential crisis. Stephen Hawking believed advanced civilizations could manipulate black holes and travel between stars. Together, these experts transformed the Kardashev scale into a framework for imagining the future of intelligence. A Type 1 civilization can harness all the energy available on its planet. Roughly 10 to the 16th watts. Capabilities include fusion power and global weather control. Earthquake mitigation and a planet-wide energy grid are also possible. Ending fossil fuels and eliminating energy scarcity are key goals. Terraforming small moons is within reach. Technologies required include fusion reactors and planetary climate engineering. A global AI infrastructure and advanced energy storage are essential. Humanity's status is currently at Type 0.72. We influence the planet, but we do not yet control it. Experts agree, humanity must survive the next 200 years to reach Type 1. A Type 2 civilization can harness the full energy of its star. Roughly 10 to the 26 watts of power is available. Capabilities include building Dyson Spheres or Dyson swarms. Mining stars and moving planets are possible. Creating artificial habitats the size of solar systems is feasible. Interstellar travel and stellar scale computation are achievable. Technologies required include megastructures around stars and industrial scale fusion. Antimatter production and star lifting are necessary. Light sail propulsion is a key technology. How we might detect them includes unusual dimming of stars. Infrared excess and missing starlight are indicators. Some stars, like Tabby's star, have shown strange dimming. But no megastructure has been confirmed. A Type 3 civilization can harness the energy of an entire galaxy. Roughly 10,036 watts of power is available. Capabilities include traveling between star systems at will, harnessing black holes and building Dyson spheres around millions of stars are possible. Moving stars like chess pieces and galaxy-scale communication networks are achievable. Technologies required include wormhole engineering and black hole power plants. Relativistic starships and galaxy-wide AI networks are essential. How we might detect them includes galaxies with missing energy, stars disappearing unnaturally, and unexplained cosmic structures are indicators. So far, no confirmed Type 3 civilization has been found. Later scientists extended the scale beyond Kardashev's original idea. Type 4, universal civilization, harnesses the energy of the entire universe. Capabilities might include manipulating dark matter and controlling cosmic expansion, engineering space-time, and creating pocket universes are possible. Type V, multiverse civilization, operates across multiple universes. This level is purely theoretical, but it shows how far the scale can stretch. According to Carl Sagan's formula, humanity is at type 0.72. We control nuclear energy, renewable energy, global communication, but we do not yet control weather, climate, fusion, planetary resources. The next century will determine whether we rise to type 1 or fall back into extinction. The Kardashev Scale is more than a ranking. It is a roadmap, a way to understand how civilizations grow, how they expand, and how they might shape the universe. Somewhere out there, Type 2 civilizations may be building megastructures. Type 3 civilizations may be engineering galaxies. The question is not whether they exist. The question is whether we will ever join them in the vastness of the cosmos, where time stretches across eons and stars burn with ancient light. The notion of intelligent life beyond our pale blue dot captivates the human imagination. Among the many questions about extraterrestrial civilizations, one stands out. How might we measure their advancement? To answer this, we turn to the visionary work of Nikolai Kardashev, a Soviet astrophysicist who dared to dream beyond the boundaries of Earth. Kardashev's groundbreaking proposal emerged during the 1960s, an era punctuated by the space race and humanity's first tentative steps into the cosmos. In his seminal paper, Transmission of Information by Extraterrestrial Civilizations, Kardashev laid out a framework not for what alien societies might look like, but for the scale of energy they could command. He posited that as civilizations evolve, their capacity to harness and manipulate energy increases exponentially. A theory that gave birth to the Kardashev Scale, a revolutionary concept that provides a lens through which to gauge the cosmic ladder of civilization. On this scale, Kardashev defined 3 distinct types of civilizations. Type 1, or planetary civilizations, have the ability to harness all the energy available on their own planet. This stage marks the control over planetary forces and the capacity to utilize resources on a global scale. Type 2 civilizations, in contrast, can capture the energy output of their entire star, a feat that implies the construction of monumental structures like Dyson Spheres, hypothetical megastructures that encompass stars to collect their energy. Type 3 civilizations, the most advanced in Kardashev's original proposal, wield the energy of an entire galaxy, suggesting mastery over billions of stars. Kardashev's vision was not confined to theoretical musings. It sparked an intellectual movement, inspiring a cadre of scientists to refine and expand the scale's implications. Among them was Carl Sagan, the celebrated astronomer who sought to translate the Kardashev scale into mathematical terms. Sagan argued that humanity, still in its technological infancy, resides at approximately type 0.7 on the scale. He famously remarked that the technologies and capabilities of a type 3 civilization would appear indistinguishable from magic to us, a testament to the vast gulf between our current capabilities and those of advanced cosmic societies. Another luminary, Freeman Dyson, introduced the idea of the Dyson Sphere, a pivotal concept in understanding how Type 2 civilizations might harness stellar energy. Dyson theorized that such civilizations could be detected by observing the infrared signatures of waste heat. His conjectures opened new avenues in the search for extraterrestrial intelligence, urging astronomers to look for the telescale signs of energy manipulation on a stellar scale. The scale's expansion continued with physicist Michio Kaku, who ventured bold predictions about humanity's trajectory. Kaku suggested that we might achieve Type 1 status within the next 100 to 200 years, a transition that would demand solving existential challenges such as climate change and resource scarcity. He speculated that reaching Type 2 and Type 3 could take millennia, underscoring the profound advancements required to ascend the Kardashev ladder. Stephen Hawking, one of the most brilliant minds of our time, added another layer of intrigue. He speculated on the potential capabilities of advanced civilizations, suggesting that they might manipulate black holes or even traverse the stars with ease. Hawking's insights not only enriched the Kardashev scale, but also painted a picture of a universe teeming with possibilities, where the limits of science and technology are continually pushed. As we ponder the implications of the Kardashev scale, we begin to see it as more than a hypothetical framework. It serves as a beacon, illuminating the path that lies before us, a journey from planetary caretakers to potential cosmic engineers. On this path, we must first achieve the status of a Type 1 civilization, a stage characterized by planetary mastery. A Type 1 civilization, as envisioned by Kardashev, would possess the ability to harness every iota of energy available on Earth, roughly 10 to the 16th watts. This mastery would translate into unprecedented technological feats, the advent of fusion power as a primary energy source, the capability to control global weather patterns, and even the potential to mitigate natural disasters like earthquakes. Such a civilization would boast a planet-wide energy grid, eliminating fossil fuel dependency and eradicating energy scarcity. The technologies required to reach this level are significant, from developing efficient fusion reactors to engineering planetary climate systems. Establishing a global AI infrastructure capable of managing these immense resources. Currently, humanity stands at a crucial juncture. As a Type 0.72 civilization, we have begun to influence our planet significantly, harnessing nuclear and renewable energies, building global communication networks. Yet, true control eludes us. We are mere stewards of Earth, not its masters. The coming centuries will determine whether we advance to Type 1 status or falter in the face of ecological and societal challenges. The journey to becoming a Type 1 civilization is fraught with obstacles, but it is also rich with potential, offering a glimpse of a future where humanity transcends its terrestrial origins. As we continue to unravel the mysteries of the Kardashev scale, the story of our place in the cosmos is just beginning. As we delve deeper into the realm of the Kardashev scale, the journey of humanity toward becoming a Type 1 civilization is a saga of ambition, discovery, and potential peril. The path from our current state to planetary mastery is marked by the need to overcome monumental challenges, both technological and philosophical. One of the most pressing challenges lies in the development and implementation of fusion power. Fusion, the process that powers the stars, promises virtually limitless energy by fusing atomic nuclei under immense pressure and temperature. Achieving controlled fusion on Earth would signify a breakthrough akin to taming fire, a source of energy that could power our civilization without the detrimental effects of fossil fuels. Experimental reactors like ITER in France are at the forefront of this scientific endeavor, striving to reach the elusive goal of producing more energy than they consume. Success in this field could propel humanity forward on the Kardashev scale, signaling a new era in energy generation and consumption. Parallel to the quest for fusion power is the need for sophisticated climate engineering techniques. As we grapple with the consequences of climate change, the ability to control and stabilize Earth's climate becomes increasingly vital. Geoengineering, which involves deliberate interventions in Earth's natural systems, offers potential solutions. Technologies such as solar radiation management and carbon capture and storage are being explored, though they come with their own set of ethical and environmental concerns. Finding a balance between harnessing these technologies and preserving natural ecosystems will be crucial as we advance. The development of a global AI infrastructure also plays a pivotal role in our transition to Type 1 status. Artificial intelligence has the potential to revolutionize how we manage and distribute energy, optimize resource allocation, and even predict and mitigate natural disasters. A sophisticated AI network could serve as the nervous system of a planetary civilization, coordinating efforts to ensure sustainable growth and equitable access to resources. However, this reliance on AI brings with it questions of control, ethics, and potential risks, creating systems that may outpace human understanding. As humanity strives for planetary mastery, the geopolitical landscape will inevitably shift. The transition to a Type 1 civilization requires unprecedented global cooperation, transcending national boundaries and cultural divides. International collaborations in science, technology, and policymaking will be essential. Organizations like the United Nations and new global coalitions will need to play a pivotal role, fostering dialogue and unity to address challenges that no single nation can tackle alone. Beyond the immediate concerns of energy and climate, a Type 1 civilization will also need to consider the ethical dimensions of its power. The capability to terraform small moons or control planetary weather systems raises profound questions about responsibility and stewardship. As we gain the ability to reshape our environment, we must grapple with the consequences of wielding such power, ensuring that our actions do not lead to unintended harm or disruption. Yet, as we look to the stars, the Kardashev Scale invites us to contemplate what lies beyond the confines of our solar system. Type 2 civilizations, those capable of harnessing the energy of an entire star, offer a glimpse into a future where humanity might extend its reach to the stars. The concept of Dyson Spheres or Dyson Swarms, vast arrays of solar collectors encircling a star, captures the imagination. The technical challenges of constructing such megastructures are immense, requiring materials and engineering feats that are currently beyond our grasp. However, theorists propose that advances in nanotechnology and material science could one day make these constructs feasible. The search for Type 2 civilizations has also invigorated the field of astronomy. Astronomers are on the lookout for unusual astronomical phenomena that could indicate the presence of such advanced societies. Stars exhibiting strange dimming patterns like Tabby's star have prompted speculation about the existence of megastructures. Though no definitive evidence has yet been found, the search continues, driven by the hope that we might one day detect the unmistakable signature of a civilization far more advanced than our own. As we envision the potential of a Type 2 civilization, we also consider the implications of interstellar travel. Such a society would possess the ability to journey between stars, colonizing new worlds and spreading life across the galaxy. Concepts like light sail propulsion, which uses the pressure of starlight to propel spacecraft, hint at the possibilities of traversing the cosmic sea. The challenges of interstellar travel are formidable, but the allure of exploration and discovery drives scientists and dreamers alike to seek solutions that could one day make these voyages a reality. The Kardashev Scale not only serves as a measure of technological prowess, but also as a philosophical guide, urging us to reflect on our aspirations and responsibilities as a species. As we stand on the cusp of transformative change, the scale challenges us to imagine a future where humanity transcends its earthly limitations, reaching for the stars while grappling with the profound questions of existence and destiny. Yet, as we explore these possibilities, we must remain vigilant about the risks inherent in such power. The road to becoming a Type 1 civilization is fraught with potential pitfalls. From environmental degradation to the threat of self-destruction through technological missteps, the journey requires not only scientific innovation, but also a commitment to ethical considerations and global unity. In the unfolding narrative of the Kardashev Scale, we find not only a roadmap for technological advancement, but also a mirror reflecting our hopes, fears, and dreams. The story of our ascent on this cosmic ladder is just beginning. As we continue to explore the possibilities, the questions of what we might become and how we might shape the universe remain ever present. As we contemplate the road ahead, the theoretical extensions of the Kardashev Scale beckon, pushing the boundaries of imagination to Type 4 and Type 5 civilizations. A Type 4 civilization, hypothetically capable of harnessing the energy of an entire universe, would wield powers unimaginable to us. This level of mastery might involve manipulating dark matter, controlling cosmic expansion, or even engineering space-time itself. Such a civilization could create pocket universes, experimenting with the fundamental laws of physics and altering the very fabric of reality. Type V civilizations, existing across multiple universes within a multiverse, stretch the limits of current scientific understanding. This concept challenges everything we know about space, time, and existence. It suggests a level of technological and intellectual sophistication that transcends our current perception of reality, making the wonders of Type 3 civilizations seem provincial by comparison. As we aspire to reach these heights, the Kardashev Scale serves as both a challenge and an inspiration. It encourages us to look beyond our immediate concerns and consider our place in the cosmos. The scale is not just a measure of energy consumption, it is a narrative of potential, a story of what we might achieve if we can overcome the barriers that stand in our way. In this grand cosmic theater, where the power to harness entire galaxies may one day be within reach, humanity stands at the dawn of its interstellar journey. The Kardashev Scale reminds us that the future is not a fixed destination, but a horizon we continually strive toward. The universe awaits, and the journey has only just begun.